For the last several lessons, I have been telling you that if one has a negative radicand with an even index, then the answer is not real. Today, we're going to find out exactly what type answer you will have. The answer will be complex. What do I mean by complex? Well, that comes later in today's lesson. The main thing you want to get from the lesson is that one can deal with complex numbers in about the same way that one deals with polynomials. You want to remember that in dealing with complex numbers, one must always put it in the standard form before doing anything. Then one must always write the answer in standard form. The square root of a negative 25 is not a real number. It's not a real number because we have a negative radicand with an even index. Since it's not a real number, it cannot be placed on the real number line. So the square root of negative 25 cannot be placed on the real number line. It's not a real number. It can be placed on the complex number plane. So it is a complex number. Now let's see how we place it on the complex number plane. But before that, we need to start with a definition. We are going to define I to be the square root of negative 1. So when you see I in a mathematical context, it means the square root of negative 1. So now, if I have the square root of negative 25, I can factor it into what is a perfect square and what's left. So I can write the square root of a negative 25 as the square root of 25 times the square root of negative 1. Now we know the square root of 25 is 5, and we've just defined the square root of a negative 1 to be I. So we have 5I, or I could write that as 0 plus 5I. Now I can graph 0 plus 5I on the complex number plane. Now for the complex number plane, my horizontal axis will be the real axis. My vertical axis is going to be the imaginary axis. And I stands for the imaginary. Now the use of the word imaginary is poor because imaginary implies that it doesn't really exist. But complex numbers do exist. They do have real applications. Even though they're not real numbers, they do have actual applications. Impedance in electronics is one example of when one will use complex numbers. But the real part is 0, so I go 0 on the r-axis. The complex part, or the imaginary part, is 5, so I go up 1, 2, 3, 4, 5 on the imaginary axis. So here is the location of the complex number 0 plus 5I. Now I've been using the word complex number, but I really haven't defined it. So now I'm going to give you the definition. And this is something that you need to put on your formula sheet and to memorize. Definition. A complex number is of the form x plus yi, where x and y are real numbers, and I is the square root of negative 1. So a complex number is of the form x plus yi, where x and y are real numbers, and I is the square root of negative 1. Look at an example. Negative 2 plus 3i is a complex number. Negative 2 and 3 are real numbers, and I is the square root of negative 1. So negative 2 plus 3i is a complex number. Now, since it is a complex number, it can be placed on the complex number plane. So let's place a negative 2 plus 3i on the complex number plane. So one needs to draw the plane. This will be the real axis. Here is your imaginary axis. And I'll just put the ticks in. And we need negative 2 plus 3i. So over here is negative 2. And I go up 3 on the I plane, I-axis. So here is the complex number, negative 2 plus 3i. One critical thing for you to remember, that is, before performing operations with complex numbers, one must write the numbers in x plus yi form. Before performing operations with complex numbers, one must write the numbers in x plus yi form. If you do not write it in the correct form before doing anything else, you could get incorrect answers. Let's look at some examples of writing the numbers in standard form. So write in standard form. 2 subtract the square root of a negative 36. I can write it as 2 subtract the square root of 36 times the square root of negative 1. I'm breaking it into what is a square and what's not. So that would be 2 subtract the square root of 36 is 6. The square root of negative 1 is I. So standard form would be 2 minus 6i. Sometimes you cannot take the square root completely. Let's look at a couple more examples. Let's start with 3 plus the square root of negative 8. I can write this as 3 plus the square root of 4 times the square root of 2 times the square root of negative 1. Now we're always going to have the negative 1 out here when you have a negative on the radical. Now 8 is not a perfect square, but 8 can be factored into what is and what's left. And this 4 is a perfect square, 2 is what's left. 4 times 2 is 8. Now notice if we multiply all three of them together, we will get negative 8. 4 times 2 is 8. 8 times negative 1 is negative 8. So I can write this as 3 plus 2 times the square root of 2 times I. Most books will rewrite this as 3 plus 2i times the square root of 2 to make sure that you do not extend this symbol too far and include the I. So you can write it either way as long as you're careful to leave the I well away from the square root symbol. But this would prevent that even coming up. So you could write as 3 plus 2i times the square root of 2. That would be standard form. Let's look at another example. 1. Subtract the square root of a negative 50. Well, 50 is not a perfect square, but I can break it into the square root of 25 times the square root of 2. And then I've got to have the square root of negative 1 because I have a negative 50. 25 times 2 is 50, times negative 1 is negative 50. Now that would be 1 minus 5 times the square root of 2, and the square root of negative 1 is I. Or I could write it as 1 minus 5i times the square root of 2.